Hello, this video is about the Arctic sea ice and some things that the media have been saying. I've heard a lot about an Arctic sea ice recovery. You can see a few Daily Mail articles here. There's been stuff about it on the blogosphere and people on Twitter, that sort of thing. The Arctic has recovered since 2012. Is that true? In a word, no. In 2012 we saw the lowest sea ice minimum on record, and by that I mean in September, when the sea ice extent reaches its lowest, the lowest figure that we got was the lowest out of any year since records began in 1979. And of the sparse records that we had before 1979, nothing came close to what we had in 2012. So, 2012, lowest sea ice extent minimum on record. It was a significant figure. It was unprecedentedly low. In 2013, the minimum was significantly higher than a lot of people predicted. It was higher than 2010, 2011 and 2012. It wasn't higher than 2009. So a lot of people said that was a sign of a recovery, including the Daily Mail. It isn't. The fact that one year was higher than the lowest sea ice extent on record means absolutely nothing. And it does mean something, because there was a certain surprise that we could recover even to this extent. I'll talk more about that later with regards to the weather conditions that produced such a so-called recovery. But is it a sign that the Arctic is recovering? Is it the sign that in 10 years' time we will see a healthy Arctic like we saw in the 1980s? No it isn't. I think SkepticalScience.com illustrates this rather well. So this is their GIF animation. GIF is actually what you should call it. I'm not going to call it GIF because it is pronounced GIF. Anyway, that's something for another day. You can see their so-called escalator. You get some upticks and people will shout recovery when you get an uptick, but you get of course more downticks than you get upticks, so the overall trend is very much down. Notice that there was a similarly large uptick in 1996. I'll come back to this later. These two look very similar. Yeah, that is a significant point, which I will come back to later. You are going to get some natural variance between years. An overall negative trend does not mean that you can't get years that have more sea ice than the previous years. You're not going to get a monotonic year-on-year decline. That is not going to happen. It's like the cold winter in America this year was not prevented from happening by global warming. These things can still happen. There is still a year-on-year variance. All global warming means is that cold events are somewhat less likely, but it doesn't mean that they're prohibited or restricted in any way. It just means that the overall temperature of the Earth is going up. In terms of the Arctic sea ice decline means that on average the Arctic sea ice is declining over time. So the idea that 2013 had a higher sea ice summer minimum figure is really meaningless when you look at the last 30 years worth of data. And of course we can go back further than 30 years in terms of observations on ships, that sort of thing. And all the indications imply that the health of the Arctic sea ice is poorer than anything we've seen in the 20th and 21st centuries, 2012 in particular. Anyway, health of the Arctic. If extent is not a great measure because it varies from year to year, then what can we use as a good measure of ice health? Well, of course extent works fair enough if you look at the trend, but let's look at volume, because of course the Arctic has a third dimension. And where are we now in 2014? Well, we're the third lowest on record. Hardly a recovery. In fact, in 2012, of course, we were the lowest on record. And you see this blue line. This dark blue line is where we were in the summer of 2013, after the slightly better summer we had in 2013. So we upticked a bit here, with fourth lowest on record. But after a mild winter, we're now the third lowest on record. So every other year has still managed to beat us apart from 2012 and 2011. So it's hardly looking great. Of course, this red line here is 2007. 2007 was the year when everything changed. I don't want to be too over dramatic, but in 2007 there was a lot of ice loss due to some very unfavourable weather conditions and heavy sea ice export. And after 2007, we've seen we saw a notable decline in sea ice health after 2007, and we have not recovered from that. You can see 2007 is still here, significantly above where we are now. You can see that in the 1980s, the sea ice volume was somewhere in this pale grey area. These grey areas represent standard deviation, so this is one standard deviation from the mean, this is two standard deviations from the mean. And in the 1980s we were somewhere up here. Because of course this is the mean of the last more than 20 years, so we started further up here. And we've gone down here. And even though the extent of the sea ice doesn't decrease every single year because of natural variation, surprisingly the volume more or less does, because the volume is less likely to be affected by individual summers than the extent. The extent, the two-dimensional surface of the ice, can be affected more than the overall ice content, as you might expect. Of course, even then there are exceptions, like we saw in 2013. We're up here. So, in terms of volume, we're not doing very well at all. Third lowest on record. Very little sign of a recovery there. And of course, this is the trend line. The source is at the bottom of the page, by the way. I'll try and get a bibliography in the description so you can see all these sources. This is the volume trend from the biomass model, the same one I just showed you previously. You can see the trend is down. This is the linear trend. We've got one standard deviation from the mean, two standard deviations from the mean. You can see we've been quite significantly below the linear trend recently, and we've just come to about the linear trend now. So the linear trend was still very much going down. Not much sign of a recovery. There's the 1996 uptick again, you can see that, and the 2013 one. Yeah, I'll come back to that, it's important. Sea ice thickness. So of course it's important to know how thick the ice is, because thick ice survives summer melt better. A thicker Arctic is a healthier Arctic. Also, the saying would go if such a saying existed. So these are two different models, modelling the Arctic sea ice thickness for the last 3 years. In the case of the top model, I can't get anything previous to that, because the model updated in 2012. I actually do have the last 10 years worth of the previous model for somewhere around September on my YouTube channel. So it's called the Biomass, I think something like Biomass 1990 to 2010. September 15th, something like that, so feel free to check that out. So, if you look at this one, the biomass model, from the inter-year comparison, if anything, 2014 looks worse off than 2012, and bear in mind this was before the bad melt, because in June the melt season is only just starting to get underway in June. This is 2013. And this is 2014, so this is June the 1st, so today, or yesterday, depending on what part of the world you live in. I don't know when this video is going to be uploaded. Okay, so in terms of this, in the Canadian archipelago, we've had some sea ice retention. You can see that there's some sea ice retention in the Beaufort Sea here as well. It's not all doom and gloom, but on the whole, again, in the thickness, there's very little sign of recovery. Rather disturbingly, actually, if you look in the Siberian part of the Arctic Ocean, it looks considerably thinner than it has done in previous years. I'll come back to this because it is an important point. Now, notice that these two models aren't identical. I've tried to make the colour scheme as similar as I can, but the problem with this is that these models, this model in particular, tends to overestimate how much ice there is in the Arctic. I know this is true because of the sea ice buoys, which are periodically report how thick the ice is, and I'll come back to the sea ice observations, but these are still useful for inter-year comparisons. And you can see this model, the Topaz 4 model, again shows a year-on-year decline. Again, we've got a little bit more ice in the Canadian archipelago than we did have in 2013, so this is sort of where the idea of a recovery is coming from. And indeed, there is some thicker ice. Indeed, I'm not going to deny that. That definitely is true. But even in 2012, this model is still picking up what these two models are picking up roughly the same thing, that there was still more ice, more thick ice, in a large part of the Arctic in 2012, even if we may have seen some small recovery after the summer of 2012, the summer melt of 2012. Okay, so I actually have an animation for a few more years for this Topaz 4 model, if it will load. We'll get there. Okay, so this is the Topaz 4 animation. Notice the perturbation here. When it gets to 2010, it jumps to 2012, and the ice volume seems to massively increase. That's due to, again, them updating the model. I can't get information for 2011. I noticed that the date changes from the 15th to the 1st of June again. There's a slight inconsistency that I haven't been able to resolve. So it's probably best to take the years after 2010 separately, and consider that as being some model perturbation. But you can see that over the last decade there's been there's been a gradual decline in the health of the Arctic in terms of sea ice thickness, and of course in the last few years we've seen a decline since 2012, before obviously the melt, the great melt season of 2012. Okay. So, I mentioned the sea ice buoys, so this is what I'm going on to now. We do actually have observations that tell us how thick the Arctic ice is, so we don't always have to rely on the models. And you'll notice that these figures that are showing here are significantly thinner than the models would have implied. So I tend to use the models more for distribution and inter-year comparison, because they tend to overdo it a little bit on how thick the ice is. You can see in the Beaufort we've generally got ice that's thinner than about 2 metres. Now, these brackets here are the amount of ice loss we saw in 2013, approximately, from buoys that were nearby. So, obviously these are approximate figures. So, for a buoy that's on an ice shelf 1.72 metres thick, last year it would have melted out completely, because we saw 1.83 metres of loss. So roughly speaking, a lot of this ice in the Beaufort is vulnerable. It's just not quite thick enough to guarantee that it'll be able to withstand it. Of course, there's differential melting, and some will melt considerably less. But bear in mind, 2013 was an unusual year, and I will come back to this. We would usually expect to see more melting than we saw in 2013. 2013 was a bit of an anomaly, meteorologically speaking, so you could probably add a few centimetres to these figures if we're looking at what's going to happen this year. I don't expect an ice-free North Pole this year. It will happen eventually, probably, but maybe not this year. The ice is still nearly 2 metres thick on the North Pole, approximately. And of course in the Canadian archipelago the ice is still very thick there, as indicated by the model showing, well, this is where the thickest ice is stored. Unfortunately, we don't have any buoys in the East Siberian Sea, which is a shame, because this is where all the thin ice is. This was the area most strongly affected by the melt. Last year, the East Siberian melted out much faster than the Beaufort last year, and the models indicate that this is where all the thin, poor ice is being stored. And the fact that we don't have any buoys in there is rather irritating, because we can't gauge exactly how poor the ice is. Last year, the ice was about just over a metre thick at this time last year, so it was quite thin, and I expected it was going to be even thinner last year. And the poor quality of the ice in the Siberian part of the Arctic Ocean might well be illustrated by this. This is some of the sea ice over recent days. You can see this is for the 24th of May, and we've seen an awful lot of melt. Not necessarily melt, but we've seen some open water, which might also be caused by divergence of ice, not necessarily melt. But this is the most open water I've seen this early in the East Siberian, in the satellite record. There's nothing like it before. Even in 2012, shown here, there was nowhere near as much open water in the East Siberian. So I suspect that this is due to the fact that the ice here is really poor quality. It's thin, so it just can't take the stress associated with being in the Arctic Ocean, being broken up by storms, being broken up by wind and rain, and of course warm temperatures, even in late May, when you wouldn't expect many of those things to have such a great impact, because the warm weather doesn't usually come until June. And of course, this is 2009, way back when, 2009, and of course this is what the Arctic should look like at this time of year. And indeed in the 1980s, the 1990s, you wouldn't expect the East Siberian to start breaking up for another couple of months. The IJIS satellite had the average breakup date for the East Siberian being even early August. So of course it would look very different to this, because by the time we get to early August there's going to be a lot of melt ponding. So the ice concentration would also be probably quite a lot lower. But this is unusual. It just illustrates that if the ice is recovering, then it's not doing a very good job of it in the East Siberian. So I would be quite concerned about this, to see it so early in the year. Let's have a look at the Arctic sea ice age. I'm sorry, this seems to have cut the top off. This is 2006, 2007, 2008, 2009, 2010. And this is the week 19, so this is a few weeks ago now. A few weeks ago, mid-May sort of time. I'll come back to this diagram in a second. We can see that the 2007 melt during the summer of 2007, so we're talking July, August, had a devastating impact on the ice, because you can see that 2008, a lot of the ice, a lot of the thick multi-year ice was taken out by the 2007 melt. And we can saw maybe a gradual increase in multi-year ice since then. We got up to 2011. This was the 2012 melt, which didn't seem to have such a large impact on the multi-year ice as before. But of course, that's partly because the distribution of thicker ice means that it's concentrated in the areas that are less prone to melt anyway. You can see that there's considerably less of this ice available than there was in 2006, in preparation for the 2007 melt. So here we are now in 2014, and you can see that the ice is significantly better off than it was last year in terms of the sea ice distribution. And that's definitely true. The ice is older than it was last year, generally speaking. There's more 5-year ice, more 4-year ice, that sort of thing. But even so, we're not as well off as we were in 2007. We still haven't recovered past that 1 year of melt. 2007 took us from this to this in a single year, and yet even after all these years we still haven't recovered past that 1 year of melt. We still haven't recovered from the melt of 2007. You could argue that we might have recovered from the melt of 2012 in terms of this metric, but not from 2007. So if we're looking at a recovery, we're not looking at any sort of sustained recovery yet. To argue for any sort of recovery, it's going to take a few more years. Maybe if we saw a couple more 2013s, it could happen quite quickly. I don't think that's going to happen. This is a diagram provided by the National Snow and Ice Data Centre. It shows the sea ice age in March. So again, we're looking at the ice age in spring. And I've illustrated a few important years here. This is 1996, which I keep alluding to. I will come back to this, but 1996 was a recovery year like 2013 was. 2007 was that devastating year. You can see in the diagrams where we saw a loss in all the second year, third year, fourth year ice. This was devastating to the ice in 2007. And then we've got the melt of 2012 and the recovery year of 2013. When I say recovery year, assume I'm saying it with the inflection in my voice that implies inverted commas. And of course you can see that since 2013 we've seen an uptick in the Arctic ice since then. Again, we're not as well off as we were pre-2007, and of course if you look back all the way back to the 1980s, we've got a long way to go in terms of any so-called recovery. Now, I'm going to talk about the significance of 2013. why it's been brought up in the media, is it important, what's going on here? Now, it's not a coincidence that the 1995 to 1996 couple look rather similar to the 2012-2013 couple. There was a so-called recovery in both years. In fact, in 1996 it was very prominent. The Arctic sea ice was one of the highest minimums on record. Actually, this is the monthly Arctic sea ice extent, so it's not the minimum, but the same pattern would be shown in the minimums. This is the September average. So, of course, we have a similar pattern in 1996 as we did in 2013 in terms of this so-called recovery. So, what was special about 1996 and 2013, and were these years special? And the answer is yes, these years were special. And it was the years that were special, not some sort of reversal of global warming. So these are two meteorological patterns that we see in the Arctic. The one on the left is the equivalent of hell, and the one on the right is the equivalent of heaven, I guess. If you see the one on the left, that's basically an indication that the ice is going down the toilet. This is a dipole anomaly. High pressure over Alaska and the Beaufort Sea, low pressure over Siberia. This sort of setup, if it's prolonged, is extremely bad for the sea ice, and this is what we saw in 2007. There are a multitude of reasons why this is. Firstly, high pressure over the Alaska and the American side of the Arctic encourages sunshine, not much cloud. So of course there's going to be a lot of the sun's going to be beating down the ice. We're going to get heavy melt without clouds or precipitation indeed. And of course the high pressure also encourages so-called blowtorch conditions, where warm air moves up from Alaska into the Arctic, and we get severe melts in the Beaufort Sea. This is the Beaufort Sea here. This dipole also encourages winds to point towards the UK in this part of the Atlantic part of the Arctic. This is extremely bad because in the Greenland Sea there is a current of ice, current that causes the sea to flow south down past Greenland. This is basically the sewage works of the Arctic. It's dumping all this ice into the Arctic, into the Atlantic. Once you get ice flowing down the Greenland Sea, it never comes back. It's the event horizon. This is, if it wasn't for this so-called transpolar drift, then the Arctic ice would be able to, other factors notwithstanding, gain ice every single year and get thicker year upon year. This stops it from happening largely because a lot of the ice that we do get is dumped into the Atlantic Ocean, and typically this takes several years for this to happen. There's a so-called Beaufort gyre which circulates the ice in this sort of way, and then eventually some of it will continue circulating whilst others will flow into the Atlantic. This sort of pattern with high pressure here and low pressure here encourages more sea ice to flow through the Greenland Sea. It's a very bad pattern. So again, it's a combination of high temperatures, not much cloud, and high sea ice export that makes this pattern a nightmare. The dipole is because, of course, we've got high and low, so it's like a magnet really, the positive and negative end. This pattern, or almost like a tripole, if you will, it's called PAC is short for persistent Arctic cyclone, and this is a pattern where you get low pressure over the central parts of the Arctic and high pressure over the continents, although these high pressures are not really significant. The significant aspect is the lower than average pressure over the central parts of the Arctic. This is the best condition that you can really get. This promotes a lot of cloud, it promotes some snow, and snowfall is always good, and lower than average exports. There are disadvantages associated with this as well. You don't want really severe storms over the Arctic, because severe storms come with things like wind and waves, and they do a great job of chopping up the Arctic into little bits which can be more easily melted by the sun when it eventually does come out. The thing about 2013 though was that the Arctic cyclones were relatively weak despite being persistent, so we didn't get the strong winds associated with all the bad aspects of the Arctic cyclones. In 2012, incidentally, we did get a cyclone that did do a lot of damage. It was christened the Great Arctic Cyclone of 2012. This individual cyclone was over here in the Trikini Sea, and it came at the end of August, and it did a lot of damage to the sea ice that was still left, and there wasn't an awful lot of it left by then anyway. It wasn't responsible for the sea ice minimum, although it did make the minimum go even lower than it would have otherwise gone. But instead of having one nasty cyclone that damaged the Arctic, what we had is weak, persistent, friendly cyclones in 2013, and this is extremely significant. So this is from. Sorry, I haven't quoted the source here, so I will say that. I'll say it in speech. This is from NOAA, NOAA, National Oceanic something or other. So I just need to make sure that that's credited. These are some re-analysis from them showing some pressure patterns for various years. So we've got 2013 here. We can see this pattern I was talking about. We've got low pressure in the central, lower than average pressure in low pressure in the central Arctic, high pressure surrounding. Of course, this isn't perfect. I mean, we don't ideally want high pressure to be here, but generally speaking, this is a very good situation. 2013 was good. In terms of this pattern. 1996 was even better, if anything, than 2013. You can see that this area of low pressure, persistent area of low pressure, is even larger. Notice that this is actually an average of the conditions throughout the summer, from early June to early September. 1st June to 1st September. So these are just averages. These are not individual cyclones, of course. The cyclones tend to come and go. But these 2 years were similar, persistent Arctic cyclones in both. The difference between 1996 and 2013, if there was a difference, is that in 1996 the cyclones were stronger. It's questionable whether a year like 1996 would have been beneficial, actually, because the cyclones in 1996 were the sort of more damaging sort. They did bring the winds and the waves. Remember though, in 1996 the ice was a lot thicker, so winds and waves might not have been so much of an issue for it. 2013 was almost the perfect scenario. It was a scenario where the cyclones were just strong enough to produce the cloud, the snow, and none of the high exports, but not strong enough to produce the wind and the waves. You can't really have asked for more perfect year. Okay, so now we go to 2007, and you can see what I'm talking about with the dipole here. Loads of low pressure over Eurasia, massive amounts of high pressure over Alaska. This is the doomsday scenario, and that's what we got in 2007. We got something resembling this in 2012, but it was much weaker. You could barely call it a dipole in 2012. The rather disturbing thing about 2012 is the meteorology was significantly better in 2012 than it was in 2007. So the melt in 2012 was rather unprecedented. So despite okay-ish conditions in the Arctic in 2012, we still had very high melt rates. And that's something we should be worried about. If even an okay-ish year can produce worse than the doomsday year back in 2007, if our ice has got so weak that it can't even stand an average scenario, 8 years down the line? So it's something to consider. This is the average, of course. Let's see that the average is the average conditions for the Arctic. You can still see a very weak dipole here, which would so even in an average year you would sort of expect this sort of pattern to be evident, but clearly 2007 was very anomalous. To conclude, was 2013 a recovery year? Yes, in the sense that the Arctic did improve in health. The thickness improved somewhat, the volume did improve a little bit, the extent improved, most things improved, but only by a relatively small amount. it was not a trendsetter. There's no evidence that this is going to be a trendsetter. There's no evidence that it's anything more than a one-off year caused by a meteorologically perfect summer. Are we going to get a perfect summer this year? We haven't had a perfect summer so far. Well, perfect spring so far. Currently, in terms of extent, we are currently the 4th lowest on record in terms of extent. You've seen in terms of volume, we're the 3rd lowest in terms of volume. The East Siberian Sea is the worst I've literally ever seen it. And the buoys do not indicate that there is an awful lot of thick ice around. So I can't predict with certainty what's going to happen this year, but I would be very surprised if the sea ice was as healthy as it looked this time come September last year. I'm willing to be proven wrong. We could get another 1996/2013 this year. But how long is it going to be until we get another 2007? And if a 2012 could produce the lowest on record, what will a 2007 do if it came, say, this year? I venture that a 2007 coming this year would certainly be a record-breaking year. So, I hope that puts a few misconceptions to bed. Thank you very much for listening.